Hello dear student, greetings for the day. Welcome to Time classes. This session is on the topic Parallel Axis Theorem, which comes in the chapter System of Particles and Rotational Motion. Hope you are well aware that this concept is very important, especially from competitive exam point of view. So in this session, we will be discussing the concept of Parallel Axis Theorem. Along with that, we will discuss how to apply parallel axis theorem for solving the numericals. Alright, so shall we start the session? Yes, so let's start. What is parallel axis theorem? See the statement of theorem. The moment of inertia of a body about any axis is equal to the sum of its moment of inertia about a parallel axis passing through the center of mass and the product of mass of the body and square of distance between the two axes. So, what does that mean? See, let us consider a body of any shape. Okay, we are considering a system of particles, and let us consider that this point is the center of mass of the system. Alright, now I am considering an axis passing through the center of mass. Okay, let us name that axis as CM. Okay. Now, I am considering one more axis which is passing through another point of the body, but the second axis, let it be XY, it is exactly parallel to the axis passing through center of mass. And let us take R as the distance between the two axes. Okay. So, we have considered two axes. First one is an axis passing through center of mass. We just named it as CM, and we are considering one more axis XY, which is exactly parallel to the axis passing through center of mass, and now I have considered R as the distance between the two axes. Okay. So, according to parallel axis theorem, the moment of inertia of this system about the axis XY is given by the sum of moment of inertia about the axis passing through center of mass and the product of total mass of the body and square of distance between the two axes. So, what does that mean? If you know what is the moment of inertia about an axis passing through center of mass, then you can find out the moment of inertia about another axis which is parallel to the axis passing through center of mass. Okay, clear? Now, we are going to see how to apply this parallel axis theorem for solving the numericals. Okay, shall we proceed? Before moving on to the application of parallel axis theorem, you have to be familiar with the equations to find the moment of inertia of certain regular shaped bodies. Okay, so let us consider one by one. First of all, we can consider a uniform rod. So, let us consider a uniform rod. Let L be the length of that rod, okay, and let us consider M as the mass of the rod. Alright, so here we have to learn two equations. First of all, we are considering an axis which is passing through the center of mass of the rod, and also it is perpendicular to the plane of the rod. And if you consider that the rod is rotating about this particular axis, the equation to find the moment of inertia is given by C ml square by 12. Okay. So, if you know this equation, then by applying parallel axis theorem, you can find the moment of inertia of the body about another axis which is passing through one of its ends as well. Okay. The only condition is that the second axis should be also perpendicular to the plane of the rod. That means both the axes should be parallel to each other. So, according to parallel axis theorem, the moment of inertia of this rod about the end axis is given by the sum of moment of inertia of the rod about the axis passing through center and product of mass of the rod and square of distance between the two axes. See here, what is the distance between the two axes? Definitely it is L by 2, right? So L by 2 the whole square will give you L square by 4 over here. And well, we know what is the equation to find the moment of inertia of a uniform road about the axis passing through center, right? What is that? ml square by 12. You can substitute it. You will get ml square by 12 plus ml square by 4. On calculation, this will give you ml square by 3. So in this way, we can apply parallel axis theorem to find the moment of inertia of a body about any axis which is exactly parallel to the axis passing through center of mass. Clear? So let us move on to the next case. So next case is that of a circular ring. Okay. So let us consider a circular ring which is having mass m and radius r. Okay. So here we have to study two equations. The first equation is mr square, which is the moment of inertia of the ring about an axis passing through its center and perpendicular to its plane. Now if you consider another axis about its diameter, which is actually parallel to the plane of the ring, the equation to find moment of inertia is mr square by 2. Okay. So if you know these equations, you will be able to find the moment of inertia of this ring about another axis which is tangential and parallel to its diameter. So let us see how to apply parallel axis theorem to find the moment of inertia of this ring about a tangential axis which is parallel to its diameter. See, this is a tangential axis parallel to the diameter of the ring. Let us name the axis as TG. Okay. So if you want to find the moment of inertia of this ring about the axis TG, then according to parallel axis theorem, this is the sum of moment of inertia of the ring about the diameter axis, because TG is parallel to the diameter axis, right? Yes. And the next term is the product of mass of the ring and square of distance between the two axes. Okay. So here see, what's the distance between the two axes? Yes, that is the radius of the ring itself. So you will get here r square. Okay. So now we can substitute the equation for I diameter, which is of course mr square by 2 plus mr square. So here you will get the answer as 3 by 2 mr square, right? Clear? Now let us consider a disk of mass m and radius r. Okay. So in the case of disk, the equation to find the moment of inertia about an axis passing through center of mass and perpendicular to its plane is mr square by 2. And if you are considering an axis passing through its diameter, then the equation to find moment of inertia is mr square by 4. So here also we consider a tangential axis TG which is exactly parallel to the axis passing through its diameter. So in order to find the moment of inertia of the disk about the axis TG, we can apply parallel axis theorem. According to the theorem, this is given by the sum of moment of inertia of the disk about the diameter axis and product of mass of the disk and square of distance between the two axes. See here also the distance between the two axes is nothing but the radius of the disk, right? Yes. So in the next step, you can give the substitution for I diameter, which is mr square by 4 plus mr square. So this will give you 5 by 4 mr square as the equation to find the moment of inertia of a disk about a tangential axis parallel to its diameter. So hope now it is clear for you how to apply parallel axis theorem. So let us discuss a question. Read the question. A uniform square plate of side L has mass m. The moment of inertia of the plate about the axis through any corner normal to the plane of the square is dash. Okay. So before discussing the question, we have to see what is the equation to find the moment of inertia of a square plate. Okay. We have just seen what is the equation to find the moment of inertia of a uniform rod of length L, right? What was that equation? It was ml square by 12. So instead of a uniform road, suppose if you are considering a rectangular shaped lamina or a rectangular plate, then you have to include the term representing breadth also, right? So the equation to find the moment of inertia of a rectangular lamina about an axis passing through its center and perpendicular to its plane is given by m into L square plus B square divided by 12. Now, if you are considering a square lamina instead of a rectangular lamina, then we have to make a small change in this equation. We know for a square, length is equal to breadth, right? So, if it is a square lamina, we can write this equation as L square plus L square. So, that is for a square lamina and this one is for a rectangular lamina. Okay. So, this will give you 2ml square by 12, which is finally ml square by 6. Okay. So, by heart the equation. This is the equation to find the moment of inertia of a square plate or a square lamina of mass m and length L about an axis passing through its center and perpendicular to its plane. Okay. Now, let us come back to the question. Here we are considering a square. Let us draw a square. The square is having mass m, which is concentrated at its center, and let us consider L as the length of the square plate. Okay. Now, we are asked to find the moment of inertia of the square plate when it is rotating about an axis through any corner. So, let us consider a corner of the square. We are considering an axis passing through this corner and the axis should be normal to the plane of the square. Okay. You have to keep it in mind. This axis is perpendicular or normal to the plane of the square. So, let us name this axis as xy. Okay. So, we are asked to find out the moment of inertia of this square plate about the axis xy. Okay. So, how you will apply parallel axis theorem? See, here this axis xy is actually parallel to the axis passing through center of the square plate, right? If you are considering an axis OO dash which is passing through the center of the square plate and normal to the plane of the square plate, then this axis xy is also normal to the square plate, normal to the plane of the square plate, right? See, here this axis xy is parallel to the axis passing through the center OO dash. Why? Because OO dash is normal to the plane of the square plate. XY is also normal to the plane of the square plate. So, XY and OO dash, they are exactly parallel to each other. So, definitely we can apply parallel axis theorem here. Okay. So, according to parallel axis theorem, IXY can be written as the sum of, what is the first term? The axis XY is parallel to the axis OO dash. So, the first term must be the moment of inertia of the square plate about the axis OO dash. And the second term is, as usual, the product of mass of the square plate and distance between the two axes. So, here you have to find what is this distance. What is the distance between these two axes? That distance is actually half the diagonal of the square, right? Let us take this distance as A. That is actually half the diagonal length. We can easily find out the diagonal length of the square because this is a right angle triangle. So, by applying Pythagoras theorem, you can write the diagonal length as square root of L square plus L square, which is equal to root 2L. Isn't it? So, what is the value of A? Half the diagonal, root 2L divided by 2. This will give you L by root 2. Okay. So, here what is the distance between these two axes? We got it as L by root 2. So, here you can write L by root 2 the whole square. So, this will give you what is moment of inertia about the axis OO dash. OO dash is an axis passing through center of the square plate and it is normal to the plane of the square. So, we already got the equation for the same as ml square by 6. So we can substitute for I/O dash as ml square by 6. And the next term is m. L by root to the whole square will give you L square by 2. Okay. So on solving this, we can take ml square common outside. So you will get 1 by 6 plus 1 by 2. Okay. So what is the answer here? Yes, definitely it is 2 by 3 ml square. That is option A. So I hope now you are a little more clear about the method of applying the concept of parallel axis theorem for solving the problems. So we will discuss the next question. So read the next question. Two disks X and Y of equal mass m and radius r are connected to form a single rigid body as shown in figure. The moment of inertia of the system about an axis passing through the center of X and perpendicular to the plane of X and Y will be dash. See here, we are considering two identical disks, both having mass m and radius r. Okay, so let us take r as the radius of both the disks. Okay, so these two disks are connected to form a single body. Okay, so what you have to find is the moment of inertia of the entire system. System in the sense you are considering both the disks together. Okay, so we are asked to find the moment of inertia of the entire system about which axis. We are considering an axis passing through the center of X. Okay, so I am drawing here an axis passing through the center of X. That axis is actually perpendicular to the plane of the disk. Okay, so let us name that axis as X itself. Okay, so we are asked to find out the moment of inertia of this entire system about the axis X. Alright. So moment of inertia is a scalar quantity. So if you have multiple particles in a system, then we will just add the moment of inertia of each particle about that particular axis, right? So here we are having two disks in our system. So to find the moment of inertia about the axis X, we will just take the sum of moment of inertia of the first disk about the axis X and moment of inertia of the second disk about the axis X. So this is what we are going to do. Okay, hope the concept is clear. Moment of inertia is a scalar quantity. So if you have a system consisting of multiple particles, then the total moment of inertia of that system about a particular axis will be just the sum of moment of inertia of each particle about that particular axis. Okay, so here we are having a system consisting of two disks X and Y, and if you want to find the moment of inertia of the entire system about the axis passing through the center of X, then you have to take the sum of moment of inertia of each disk about the axis passing through center of X. Okay, now let us give substitution for these two terms. So what is the first term? Moment of inertia of the first disk about the axis X. With respect to the first disk, the axis X is passing through its center and perpendicular to its plane. So we have already seen the equation of moment of inertia of a disk about an axis passing through its center and perpendicular to its plane. What was that? Yes, it was mr square by 2, isn't it? So we can give the substitution for the first term as mr square by 2. Okay. Now come to the second term. Second term means it is the moment of inertia of the second disk about the axis passing through the center of the first disk. Okay. So see here, with respect to the second disk, this axis X is actually parallel to the axis passing through the center of the second disk, isn't it? If you consider an axis Y which is passing through the center of Y and perpendicular to the plane of Y, then definitely these two axes X and Y, they are parallel to each other because both are passing through the center of the respective disk and both are normal to the plane of the disk. So definitely the two axes X and Y, they are parallel to each other. So we can definitely apply parallel axis theorem to find the second term in this equation. Okay. So how will you apply the theorem over here? Since the axis x is parallel to y, the first term in this equation should be the moment of inertia of the disk y about the axis y. Okay, so what is the equation? Yes, it is mr square by 2 because with respect to the disk y, the axis y is passing through its center and perpendicular to its plane. Now what is the next term in this expression? It is the product of mass of the disk and square of distance between the two axes. So from the figure find out what is the total distance between the two axes. Yes, it is 2r, right? So here you will write 2r the whole square, which is actually 4r square. So what you are finally getting is mr square by 2 plus mr square by 2 plus what is that? 4mr square, right? So you will get here 2mr square by 2 plus 4mr square. That means mr square plus 4mr square. So the final answer for this question is 5mr square, which is there in option B. Clear? So that is all in this session. I hope now you are well clear with the concept of parallel axis theorem, and you are also thorough with how to apply the concept of parallel axis theorem for solving application based questions. The only thing you should keep it in mind is that you have to learn certain equations to find moment of inertia of some regular shaped bodies. If you keep those equations in mind, you can easily apply parallel axis theorem for solving application level questions. So I believe the session is useful for you. So practice more questions from parallel axis theorem. Hope you have enjoyed the session. Thanks for watching. Have a nice day. Thank you.